In this video, I'm going to be covering question 5, part A from the 2019 AP Calculus AB free response no calculator allowed portion of the test. If you want to see A, B, and C, I cover each of those in their own individual videos, so please go check out my other videos. Whenever I see a graph on any AP Calc problem, I always want to make sure I know what this is the graph of. And so they're telling us here that R is the region enclosed by these two graphs. By g of x equal to the negative 2 plus 3 cosine of pi over 2x, and h of x, which is equal to 6 minus 2 times x minus 1 squared. If you know what the shapes of your equations normally look like, your parent functions, right? A cosine function generally has that up and down movement going on. That is what is looking like the bottom equation here. That g of x looks like that equation there. And an x squared graph is sort of your parabola graph, either doing this or doing that. And so this upper graph has that shape to it. If you cannot recognize those parent functions in those parent graphs, what you need to do in that situation is take this point here, x equals 0, plug it into your g equation, and you would end up seeing that you get out a y value of 1. So you know that that graph would hit there. Plug 0 into your h of x equation, you would have gotten out a y value of 4, and that would have told you that that dot should have gone right there. But you got to know your parent functions. You should be able to kind of look at that graph and know just by looking at it which graph is which. Now that I know what the graphs are, I come down and see what are they actually asking me for. So they want me to find the area of that region. So what we're doing here is the area between two curves setup. The area between two curves, this is an integral setup that you just have to know how to do. So the area between two curves you find by taking the integral from a to b, wherever that region begins to wherever that region ends, of whichever equation is on top minus in parentheses whichever equation is on bottom dx. And remember, when you subtract that second equation, the full equation is getting subtracted, so you need parentheses around that whole thing. Looking at what we saw at the beginning, we can see that our top equation in here would be that h of x equation, and our bottom equation, the one that's below it, is going to be our g of x equation. So now we can start building out this definite integral. So we would start here. This would be the integral from our left bound, our lower bound, which would be over here on this side, which is happening at x equals 0, to where the region ends, which would be on the right-hand side over here at an x value of 2. Then the top equation we said is our h of x equation, which would be this equation right here. So this would be 6 minus 2 and then x minus 1 squared. Nope, not a dx yet. That's just the top equation. Minus, in parentheses, always the bottom equation. So our bottom equation is going to be this g of x. So negative 2 plus 3 cosine of pi over 2x. Close it there and then dx. So that's the definite integral we need to solve, and so we just kind of want to work our way through this a chunk at a time. Technically, you could always break this up into two different integrals that you wanted to. You could go the integral from a to b right here, separate that top and that bottom. I like to put it together all at once. You know, you could separate it there like that and go 0 to 2 if you needed to. But again, if I don't have to, I like to kind of keep it all together as one problem and just do it all at once. So to do this one, the first thing I need to do is kind of simplify it down, clean it up so that it's ready to take that definite integral. When I look at my first chunk, I have this x minus 2 squared right here. If you leave it as is, that's technically going to be a u substitution in the middle of this problem. Well, I don't want to do a u substitution if I don't have to. And so when they've got something like x minus 1 squared, and I can do it real quick, I can FOIL it, right? I can really expand that out. X minus 1 squared, and we go ahead and have a negative 2 sitting on the front of that. This is really negative 2 times x minus 1 times x minus 1. I can do that foiling real quick and easy, and I'd much rather do that than end up with a u substitution in the middle of the rest of this problem. So from there, kind of doing our multiplication, we end up with x squared minus 1x minus 1x, and then minus 1 times minus 1 gets a plus 1. We get negative 2x squared. Combine those like terms in the middle, negative 2x plus 1. And then sort of the last move here would be to distribute that negative 2. So I get negative 2x squared. Negative 2 times negative 2 gets me a plus 4x. And negative 2 times 1 gets me a negative 2. So I'm going to now replace that into this problem for this piece right here. So I come through and I'm going to go the integral from 0 to 2 of 6 minus 2x squared plus 4x minus 2, and then minus, and as I come through, I'm going to go ahead and distribute this negative sign into everybody. So that negative negative is going to give me a plus 2, then distributing the negative down here gives me a minus 3 cosine of pi over 2x dx. And again, don't rush in to take your antiderivative until you're ready. Look for as much simplification as possible. I've got a positive 6 here, I've got a negative 2 and a positive 2, so those are going to end up canceling each other out, and now I can rewrite this as the integral from 0 to 2. Nothing happened to that 6 because these guys canceled out, minus 2x squared plus 4x minus 3 cosine of pi over 2x dx. A little bit of algebra I would much rather do than a whole bunch of u substitutions and some nastier antiderivative work. So that's the method I chose to go with. And now I just work my way through this a chunk at a time. So I take the antiderivative of 6 following that power rule. A number by itself is going to gain a letter back. So this is going to be 6x. Then here I'm going to add 1 to the power, divide by the new power. So I get negative 2x to the third divided by 3. Plus, again, there's an unwritten 1 there. I add 1 to the power, divide by the new power, minus, and now over here, this is a special case. The constant up in front, that comes along for the ride, just like that 4 came along for the ride right here. That 3 is going to come along for the ride. And now you just need to know, I call them special cases because they're antiderivatives, just like they're derivatives that you had to just have memorized. So if I have the antiderivative of a cosine of a number times x, and I recommend memorizing it with this number inside here, this ends up becoming 1 over whatever that number is, and then cosine came from sine. And so here our number inside, our a value is pi over 2. So this is going to be times 1 over a, so 1 over pi over 2. Cosine comes from sine, and then this is pi over 2x. And because this is a definite integral now, this would be evaluated from our lower bound of 0, so from x equals 0 to x equals 2. And here I do what I just call top minus bottom. I'm going to take the top value and plug it into those equations, and I'm going to subtract off the bottom value plugged in. Again, if I can clean this thing up a little bit before I do that algebra, I would much rather do that now than later. So what I can do, there's not a whole heck of a lot. I've got 2 over 3. I'd rather pull that constant to the front. Think about fractions up front like that. Then 4 over 2, I could cancel that 2 out of there. That's going to get me plus 2x squared. I flip this up. This is going to be minus, technically, if you want to look it off to the side, this would have been negative 3 times. You flip that, and that would be 2 over pi. So I end up with negative 6 over pi, the sine of pi over 2x, and then evaluated from x equals 0 to x equals 2. So we get into the end here, just a little bit more algebra. We're going to plug in our top value first. So plugging in the top value for 2 everywhere I see an x. Start with a parentheses because it's all this math. So 6 times 2 minus 2/3 times 2 to the third plus 2 times 2 squared minus 6 over pi times the sine of pi over 2 times 2. That's the first chunk. Subtract off the bottom plugged in. So 6 times 0 minus 2 over 3 times 0 to the third plus 2 times 0 squared minus 6 over pi times the sine of pi over 2 times 0. We squeezed it in just barely. And now we just work our way through this all now. 6 times 2 is 12 minus 2 to the third is 8. 8 times 2/3 is going to get us negative 16 over 3. That'd be 8 over 1 times 2 over 3, which is going to get us 16 over 3. Then this is 2 to the third essentially, so plus 8 minus 6 over pi. And now here the 2's are going to cancel, so I have the sine of pi. Well, the sine of pi is coming off of our unit circle, right? So if we remember our unit circle, pi is over here. that is the point -1, 0. The cosine value is the x value, the y value is the sine value. So the sine of pi is 0. So then this would be -6/pi times 0. Then we'll subtract off of this. The back end here has a lot of zeroing going on, which is great. 6 times 0 is 0. 2/3 times 0 is 0. 2 times 0 is 0. And now at the back end here, I have -6/pi. And then that's pi over 2 times 0. So that would be finding the sine of this times 0. So the sine of 0, which is this piece right here, that's going to be over on this side. That's the point 1, 0. So again, the x value is our cosine value. The y value is our sine value. So then the sine of 0 is 0. So then we end up with -6 pi times 0. So all of that is again going to just zero out. So when we start bringing it back together, we're really just looking at this math up in the front. I do 12 plus 8. That's going to get me 20 minus 16/3. This all zeroed out. I find my common denominator. So the common denominator would be 3. So I end up with 60/3 minus 16/3. And that's going to end up giving me out 44/3 for my final answer. And so as you come through this was 4 points. This was a big one. The first one would have come from putting this original integral together. Then the second points you get are basically, they think about it as two antiderivatives. So you would have gotten 1 point for getting the first half of that antiderivative. You would have gotten a second point for getting the second half of that antiderivative. And then from there, you'd have gotten 1 point out for getting the final answer. So a lot of algebra really on this one. And when you got algebra, just take it a chunk at a time, a chunk at a time. Don't move too fast. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.